Hi there. All right, so today we're going to talk about dividing rational expressions. The good news is that once you know how to multiply rational expressions, dividing rational expressions is easy. So if you do need a review on how to multiply rational expressions, I would suggest watching that video first so that when you come back to this one, all we're doing is adding one more step and you feel comfortable dividing rational expressions. So like I said, dividing rational expressions will be easy if you understand how to multiply them. So let's take a look. We're going to start by recalling a simple division problem from elementary school. Something as simple as 3 over 7 divided by 9/14. Now, if you can remember, the rule when we divide fractions is that we want to flip and multiply. Meaning, our first fraction is going to stay the same, so that's still 3/7. The flip part comes from taking 9 over 14 and flipping it. So 9 over 14 now becomes 14 over 9. And the multiply part comes from taking our division and making it multiplication. So 3 over 7 divided by 9 over 14 is actually 3 over 7 times 14 over 9. And now we're just going to simplify by canceling any common factors. So 3 goes into 9 3 times, 7 goes into 14 twice, and then we just multiply across. 1 times 2 is 2, 1 times 3 is 3, for an answer of 2 over 3. So with rational expressions, the same concept of flipping and multiplying is going to apply. Our fractions are just polynomial, or contain polynomials instead of regular numbers. So let's take a look at an example. X squared minus x minus 6 over 2x minus 2x minus 12 divided by x squared plus 4x plus 4 over x squared minus 10x plus 24. So first step here is we're going to flip the second fraction and change the operation to multiplication. So our x squared minus x minus 6 over 2x minus 12 stays the same. We're going to multiply, and then what was in the denominator now becomes our numerator, and the numerator drops down to the denominator. Okay. Once we have our problem set up like this, we're basically now multiplying rational expressions. So those same steps that we did in that previous video are going to apply. We want to factor each part of each of these fractions. So x minus 3, x plus 2. We're going to factor out a 2 here, x minus 6. This becomes x minus 6 times x minus 4 over x plus 2 times x plus 2. Now, in the multiplying rational expressions video, I said that the next step was we want to find the x values that make our expression undefined. That's still true here, and we do that by taking each of the factors that have an x in them in the denominator, setting them equal to 0, and finding what x equals. So I'm just going to, because I'm running out of room here, the x minus 6 is going to give us an x cannot equal 6, and the x plus 2 is going to give us a negative 2. So if you need a review on how I got those numbers, go back and look at the multiplying rational expressions video. It's a lot clearer there. At this point, you should be able to look at these denominators and say, okay, x minus 6 gives me a 6, x plus 2 gives me a negative 2. Now I want to cancel any terms that I can cancel. So I have an x plus 2 cancels and an x minus 6 cancels, and then I'm just going to multiply across. So my final answer, x minus 3, x minus 4 over 2 times x plus 2, x cannot equal 6 and negative 2. So those are part of my answers. Okay, so like I've said before, we're multiplying rational expressions, except the first step here, we have to create that multiplication problem. We have to take our division, make a multiplication, and flip that second fraction. So let's take a look at one more example. Here we have 2x squared minus 5x minus 12 over x squared plus 5x minus 6 divided by x squared plus 4x minus 32 over x squared minus x minus 42. So we're going to, I'm actually going to factor the first fraction first, just instead of rewriting it as it is. So the first fraction factors to 2x plus 3 and x minus 4 over x plus 6, x minus 1. Okay? Now my division becomes multiplication, and what I'm going to do here is my denominator is going to come to the numerator. So x squared minus x minus 42 is actually going to go in the numerator of my new fraction. I'm going to factor this so that I'm not rewriting the same things over and over again. I'm just trying to cut down on what I have to rewrite. If you need that extra step where you flip the fractions before you factor, please do so. I'm just, because of room and space, I'm going to factor while I flip. So the x squared minus x minus 42 comes to the top, and that factors to x plus 6, x minus 7. Okay. Now my x squared plus 4x plus 32, which is the numerator, that's going to come to my denominator, and that is going to factor to x minus 4, x plus 8. Okay, so I just took the denominator, put it in the numerator, put it in the denominator of the second rational expression, and then I factor them. Now I want to cancel, so I'm going to look and see, well, actually before I do that, I need to find my x value. So x here cannot equal negative 6, 1, 4, and negative 8. Now I'm going to cancel, so my x minus 4, my x plus 6 cancel, and when I multiply across, I have 2x plus 3 times x minus 7 over x minus 1 times x plus 8. Again, with my x values, x cannot equal negative 6, 1, 4, and negative 8. So hopefully that didn't confuse you too much. The previous example, if you need to go back, has the steps listed out a little bit clearer if you feel like you need to see those individual steps. But if you're able to mentally flip and then factor as you're rewriting, that'll save you a little bit of time and space, and you'll still get the final answer. So don't forget, there is a video on multiplying rational expressions on the website. I've listed the website below here that you can look at. And there are also documents in the document section for extra practice problems on both multiplying and dividing rational expressions. So feel free to email if you have any questions, and I hope you found this helpful. Thank you.